In this episode, I'm going to look at the Adeaska SQ4. This is a 4-cell lithium-ion and nickel metal hydride, nickel cadmium battery charger that can charge between 1 and 4 cells with independent charging channels per cell. So we're going to put this through its paces, check it out, and see how well this unit works. This is actually a pretty good charger. I've looked at others before, and I think this one probably has every feature that you could ever want. It will charge up to 2 amps in a single slot. So you can charge a battery at 2 amps, and the other batteries can be charged at 1 amp each. Actually, the 2 middle ones, I believe, only work they work to 1 amp, and these ones can go up to 2 amps on the outside cells. It's compatible with lithium-ion and lithium polymer type batteries. The 10440, 14500, 14650, 16340, 16650, 17650, 17670, 18350, 18490, 18500, 18650, 22650, 26500, 26650, and 32650 lithium batteries. It'll also charge nickel metal hydride and nickel cadmium in quadruple A, triple A, double A, AC, sub C, and D sizes. So this will pretty much charge all of your cylindrical type battery cells, and you can select independent charging levels for each charge. Here's our specifications. Power input, DC 12 volts, 3 amps. Output voltage. And it even has, I believe it even has a power bank in it, so you can use it to charge devices. Let's just open this thing up and see what's in the package here. So in the package, we have a power cord, a power adapter. Oh. Look at this. For use with Scientific Atlanta model IPN 430 or 4320. Now, the IPN 430 is a set-top box which is used by many carriers, including TELUS out here in the west of BC. The 430, the Scientific Atlanta IPN 430 was the PVR that was used up to the transition over to the 4K boxes. So this is actually a standard 2.5 or 3 amp, I think it's 3 amps, power supply. Well, it's a 5 amp power supply. So there you go, 12 volt, 5 amp. Universal voltage, 100 to 240, up to 5 amps outputs. I like this. And of course it's Sony Corporation. Uh-oh, I sense trouble. Here is the charger itself. Let's take a quick look at the back of this thing here. We should pop this thing apart and actually take a look inside it. I think we'll take this thing apart and see what's inside this and see how well this one's built before I test it. So this is the display controller, and here's our charging circuits here. Okay, now I've done it. Probably wrecked this thing. 4 independent charge circuits. Each got its own controller IC for each of the circuits for overcurrent protection, over charge protection. And here's our microcontroller over here. It's got a buck converter to drop the voltage down for each of the, this would be for each of the charging circuits. Build quality looks to be pretty good on this thing. I don't see anything jumping out at me that says that there's going to be a problem here. Components are all solid. Now I just have to put this thing back together and we'll test it out and see how it performs. So each of these springs fits over. These are what hold the charge contacts in place. So when you put a battery in here, it pulls the spring down. You see, that's what makes the connection for the negative terminal. So these just sit in place. Push the board back into place here. Set all of our contacts in. So I've got a couple of lithium batteries that I just discharged in the flashlights. We're going to put them on charge and observe how this thing operates. I can set them to 1 amp, or I think I can only go to 1 amp if I charge 2 of them. I know if you can charge 3, they can charge at 1 amp each. I might be able to do them at 2. We'll press the buttons on the front and see what it does. So the unit is back together. We'll just put the little feet back in place here. Okay, we'll apply a power to it. Oh, it has a charge port out as well for charging your cell phone. You use this as a power source to charge your cell phone. So the unit boots up and shows me that there are no batteries installed. And if I just install a battery here, it should automatically figure out that I've installed a battery and go into charge mode, which it does. And as you can see, it has measured the voltage on the cell and it is now going to charge. And if I press the buttons here, I've now selected 2 amp charging mode for these 2 cells. If you're charging 2 cells, you can charge them at 2 amps each. If you are charging 4 cells, you can only charge them at a maximum of 1 amp. And the 2 charge ports in the middle here have a maximum power of 1 amp. I can see, looking at the display from the angle where I am, I can see everything looks like 8s on here. So I can see it tells you what type of battery it has. It's identified these as lithium ion, but it would also say NiMH or LIFEP04, depending on the type of battery. So this automatically detects the style of battery. So let's see how long this takes to charge. Now, what you notice here is this is the charge time, how long it's been on. So it's been on 1 minute. So this will actually tell us how long it takes when the battery is charged. Oh, that's weird. Static charge here is making all these little lines light up in the display. That's going to give us the charge capacity of the cell. Once the cell is charged, it'll tell us how many milliamp hours it took to charge it. And this will also give us the resistance of the cell itself in mega ohms. And here's our cell voltage right now and our time. So let's let this thing do its job and charge these batteries up. As you can see, after only 10 minutes, we've already put in 340 milliamp hours, and the voltage has come up to 4.06 volts on one cell, and the other one's come up to 4.2 volts, charging at 2 amps. It'll be interesting to see how long it takes to fully charge the cells. 21 minutes in, we've put 710 milliamp hours into one cell, 470 into the other. So at 28 minutes, you can see the rate of charge here. You can actually see the milliamp hour meter increasing as it charges. So at this point, our cells are pretty much equal in terms of voltage. They're reaching full charge. And once it gets to become a full charge, it will actually tell me that it's full, and it'll stop charging at that point. 50 minutes in, this cell has taken on 1350 milliamp hours, and it is probably almost at a complete charge now. Been charging now for 1 hour. I believe these are 1800 milliamp hour, these cells that I'm charging here. So this, you can see this one's taken 1.47 amp hours already, so 1471. So as you can see, at 1 hour and 12 minutes, 1581 milliamp hours into this cell, 871 into this one. Now this is the one that was on the big flashlight that actually completely shut down. The other one had not shut down because it was running in dim mode a little longer. So I didn't completely discharge the cell, but I did on this one. I've now added 2 nickel metal hydride batteries that have not been charged in a very long time, and we'll see whether these batteries will even come back. There, this cell is now full. You see? This one should be getting pretty close to being full as well. Right now, the charger is trying to get this one cell here to start to charge because it's been sitting dead for so long. We'll see whether the charger will resurrect this cell or not. Okay, it looks like this other cell is starting to respond. We'll see whether this one will charge up, but it's looking promising. Took about 4 minutes there of this constant cycling to get the voltage to come up a bit, but it looks like the cell voltage is starting to come up, and that cell is now starting to take a charge as well. So we'll just monitor what's happening with the rest of the cells on here. This cell is almost full. So it's 1800 milliamp hour is the full capacity of this cell, so it should be getting to full very, very quickly here. So here we have it, 1813 milliamp hours to charge this cell, 2 hours and 17 minutes. 878 milliamp hours to charge this cell. This one only took 85 milliamp hours, and this one's still charging. Okay, I've left it going for a little while longer. I actually discharged this battery a bit and put it back on charge again. It's now taken 223 milliamp hours, and again it's listed as full. This battery here, the one that was completely dead and it took it a while before it actually got going, it's a 1700 milliamp hour cell, and so far it's taken almost 1600. So this cell itself should be coming up to full charge pretty quick. This one was completely dead. So what I'll be interested to see is when it finally does finish the charge, how much of a charge it's actually going to accept. And we're going to discharge these cells and charge them a few times, but this is the first initial charge on these ones. The batteries have not been charged in many years. But anyway, that's a quick look at this charger, and link to it is in the description. And as always, thanks for your support, and thanks for watching.